Yeah, hello everyone. So in the last class we discussed some of the topics about the number system. So here just we recapture the number systems. So what is meant by the number system? So it is a technique used to represent the numbers in the complete system. So actually we are having the four number of number systems are present, like binary number system, octal number system, decimal number system, hexadecimal number system. So we know that the number systems, what is the decimal number system means. So all the number systems have different types of the bases based on the number of digits that is present in that number system. So when we see that decimal number system, it is of base 10, 0 to 9 are the numbers, and the binary number systems are base 2, 0 and 1 is the what is the numbers, and octal number system is having that 8 digits are present. So that is 0 to 7 are the digits present in that. So its base is 8, and hexadecimal number system base is 16 because of having 60 digits in that. So here it is called as alpha numeric number system because of it is present numbers and also alphabets are present. So 0 to 9 are the numbers, and A to F are the alphabets. These are used to represent 10 to 15. So here the decimal number system, already we know that it is having a base of 10. That means 10 digits are present in this from 0 to 9. So here this is the decimal number system. So all it is the positional number systems. So here the decimal point is present 327.4. So here in this it is given that, so this is the decimal point where we are using this one decimal point. So the before that decimal point we are having the ones, tens and hundreds. So whereas after the decimal point it is called as 1 by 10th, 1 by 10th point, okay, positional value it is present. So going from left side to right side is 10 into x smaller things, 1 by 10, 1 by 100, 1 by 1000 like that. So whereas binary number system, already we know that it consists of the two digits, zeros and one, so that its base is 2. Some of the combinations it is given, like examples 1001, 100, 1110, 011, 011 like that. These are the binary number systems. So here we are showing that positional values like this. Okay, the binary point is given here. So based on that binary point, so the left side what is it is called as 2 power 0. Okay, so it should be present here. So that 2 power 0, 2 power 1, 2 power 2 like that. And the right side of the decimal binary point is 2 power minus 1, 2 power minus 2 and 2 power minus 3 up to 2 power minus n like that. Next, so here we are having example of the binary number that is in the form of the values, position values. So here 100, 1101 it is given. So when we consider the positional values of these numbers, binary numbers, so it is given, we are starting from right side to left side. So the rightmost bit that is called as LSB, and the leftmost bit is called as the MSB. So the LSB is starting with 2 power 0 positional value. So 2 power 1, 2 power 2, 2 power 3, 2 power 4 like that. Okay, so we are moving here like this. So the multiplier it is given, these are the multipliers what we are calling it as 1010, and these are the powers. Okay, 2 power 0, 2 power 1, 2 power 2, 2 power 3. So these are 1 2 3 4 are called as the weights. Okay, 1 2 4 8. So these are the weights of the 2 power 0 means 1, 2 power 1 means 2, 2 power 2 means 4, and 2 power 3 means 8. So like this we can write the weights. Next, octal number system. When we consider this octal number system, it is of base 8, and 0 to 7 are the digits present in this octal number system. So one of the example we are having, that is 74. Okay, so this is the example for that octal number system. Next, how example of a octal number with the positional values. Okay, so it is given here. So here it is given, the octal point is given. So here when we consider this octal point, to the left side of the octal point we are having that positive numbers, and right side of the octal point we are having the negative numbers. So that is power values are 8 power 0, 8 power 1, 8 power 2, 8 power 3, because it is a octal number. So here the weights are to the powers of the 8. So we can also have this example like 512.74. So in this, when we see that the power values are after that, when we consider this decimal point, so left side of the decimal point we are having the 0, 1, 2, and the right side of the decimal point we are having -1, -2, like that. So we can just add in and just multiplying that the powers with 8, 8 power 0 into 2 plus 8 power 1 into 1 plus 8 power 2 into 5, like that, plus. So when we consider that right side, so 8 power -1 into 7 and 8 power -2 into 4, like that we are considering this. Next, to the hexadecimal number system, already we know that it is a alphanumeric number system consisting of alphabets and numerical numbers. So here we are having 0 to 9 are the numbers, representing 0 to 9 are the numbers here, and A to F are to represent the values from 10 to 50. So here this is the example for the hexadecimal number system. So it is given. So here it is given FEDCBA 987654. So here 0, 1, 2, 3 up to F. So A means 10, B means 11, C means 12, D means 13, E means 14, and F means 15. So total 0 to 15 we are having. So 0 to 15 means total of 16 numbers are present, so that the hexadecimal number system has a base of 16. So it is given the example 2E6.A3. Okay, so when we are considering this one, the dot as a hexadecimal point, the left side one is the bigger one, 16 into, okay, bigger one, and right side one is the 16 into of smaller one. That means the powers are moving from when we move from right to left, what is that, at the decimal point we are having 0, 1, 2, and to the right side -1, -2, like that it is shown. So the binary number system it is giving. So what are the steps to convert the binary number into the decimal conversion? So it is the important thing here we have to consider. So for example, when it is given, the binary number is given, first you have to write that the binary number with the decimal point. So it is given 10.111 is given. So to the left side of that number, so here we are having, so here to the left side of that number we shall take that 2 power 0, 2 power 1, like that, and to the right side we are considering the 2 power -1, 2 power -2, and 2 power -3. So just simply we are multiplying this given binary numbers with these powers. Okay, so like 0 into 2 power 0 plus 1 into 2 power 1, plus after that, after the decimal point we are considering these things. That means 1 into 2 power -1, 1 into plus 1 into 2 power -2 plus 1 into 2 power -3. So after calculation of these things you will get the resultant number of 2.875 base 10, because so here it is given base 2, that is binary number is given. We are considering, what is that, we are converting this into decimal number system, that is base 10. That's why at the end we are writing that the base of the resultant number is 10. So here how it is converted. So converting the binary number into the octal number. So in the first case we have converted binary number into decimal. In the second, what is that, we are converting binary into octal. So when a binary number is given, how to write it into octal number. So in this case, first you have to write the total binary number and divide that binary number. So here we have to divide that binary number into three numbers. Three numbers you have to divide like this. So to the left side of the binary point, you have to move from LSB to MSB. That means right to left one. Right to left, three bits are we are dividing as a one group. And to the right side of that binary point, to the right side of the binary point, we have to divide that from MSB to LSB. We have to move from right side to left side. That means 1000011 like this. We are moving here like this, and to the left side here we are moving like this. So here we are dividing that three numbers as a one group. So we know that 111 it is representing 7, 100 representing that it is 4, and 2 so 010 it is 2. So 1004011. So directly at last we are writing this is the equivalent resultant of octal number that is given for the binary number. Next, how to convert the binary number into a hexadecimal number. So here what is that, in this case first you have to take that binary number and divide that binary number into 4 digits. So here we same process as the octal number system. So in the when we are converting the binary number into octal number, so we are dividing 3 numbers as a one group. But here when we are converting into hexadecimal number, you have to divide it into 4 numbers as one group. That is moving from MSB to LSB. Here like this, from right side to left side, when there is no decimal point or binary point is present in the given number. So here we are divided that 4 numbers, 4 numbers, and if any number is left aside, that means in the MSB, if the 4 digits are not present in that number, we have to add. For example, in this example it is given at last what is only 1 is left, that means only one number is present. So for this one you have to add 3 more zeros. For this 3 more zeros are added to this number, so that it will be goes to 1, and 4 ones means F, 0 1 1 1 means 7, 0 1 1 1 means 7, 0 0 1 0 means 2. Okay, so like this we were converting that binary number into a hexadecimal number. So just we have to remember that. So in this case you have to divide that given binary number as 4 numbers as one group, moving from right side to the left side when there is no decimal point is or binary point is not given. So when the binary point is given for this one, you have to move. Okay, so after that right to the right side of the binary point you have to move what is the right side, that means left to right you have to move. The dividing that number given number into 4 digits, 4 digits as one group, and you have to convert it into the hexadecimal number. So here it is given decimal number system. So here how to convert that decimal number into the binary conversion. Okay, so here the example of what is that it is given. So in this case one of the number it is given the decimal number, that is 35 it is given. So here we are when the decimal number is given, how to convert it to the binary number. So it is a very easiest one method. So here we are dividing that given decimal number with number 2. Okay, because we are converting into binary number, so you have to divide that given number with 2 successful. Okay, so here you have to divide that total number into successful divisions up to the remainder is what is up to remainder goes to what is the quotient goes to 0. So here it is dividing when it is given that 35 is given, it is a decimal number it is given. So we are dividing that 35 with 2, that means 2 17 ja, that is 34. 1 is left here. Okay, that is remainder is we have to write like this. And when we are dividing next 17 with 2, 2 8 ja is it 16, and 1 is remainder, so that's why we are writing 1 here. And 8 is divided, okay, with 2, that means 2 4 ja 8, and there is no remainder is present here. In this we are writing 0 here. Next we are having 4 is present, 2 2 ja 4, so here there is no remainder, that's why we are writing 0. Next 2 1 ja 2, and there is no remainder is coming, so in this case also we are writing 0. So like this we are dividing that total number into successful divisions, and up to last what is that, up to that number is what is the quotient should get what is either not divisible by 2, that is 1 or 0. So here after division you have to remember, it is an important point. So how we are writing this binary number? So we are writing this resultant binary number from downwards to upwards. We have to write this downwards to upwards like this. So here we are writing that into the resultant binary number is given writing like this. That means 10011 base 2. So like this we are writing. So this is the resultant conversion number. So next we are converting the given decimal number into the octal number system. So in this case, same as the previous one, the decimal number is how we are converting. That is with a successful division of 2. So here the decimal to octal means we are dividing the decimal number with a successful division of 8 here. So for example, it is given 214 is given. So there is 214 is dividing with 8 here. So 8 2 ja is 16 and 8 6 ja 48. So here when we are dividing the 214, we are getting a quotient of 26 and the remainder is 6. The next we are dividing the 26 with 8, that is 8 3 ja 24. So in this case the remainder is 2. So we cannot divide that number 3, so that's why we are writing just 80 and here the remainder is writing here. So in this case also we are writing the numbers, the resultant octal numbers from downwards to upwards. So that is from like this we are writing. The last remainder is going to first and the first remainder is going to last. So that's why. So 326 base 8 is the resultant octal number that is given for the problem 214 base 10. That means octal to decimal to the octal conversion. So in the next case, here we are converting the decimal number into hexadecimal number system. Same as the previous thing. So when we are converting the decimal number into any other system, the resultant what is that? The conversion should be taken. For example, in the case of the binary number, we have to take 2. In the case of the octal number, we are taking 8, and in the case of the hexadecimal number, we have to take 16. So here also take that first decimal number and divide this decimal number with 16 in a successful division format like this. So in this case it is given 2811 it is given. So this 2811 is divided with 16 like this. So when we are dividing it one, here we are getting a quotient of 175 and we are getting the remainder of 11. So this 11 is representing in the form of the hexadecimal format. That means it is equivalent to B. So next we are dividing that 175 with 16 and in this case also we are getting that quotient of 10 and remainder of 15. So this remainder is writing 15 is equivalent to the F. That's why we are writing F here. So after that what is we cannot divide that number 10 with 16. So directly we are writing 0 as the quotient and 10 as directly it is remainder. So 10 is representing in the form of A here. Same like the previous case also, here when we are converting from decimal to any other conversions, we have to divide it successfully and we have to write that resultant number from downwards to upwards. That means the remainders are moving from downwards to upwards like this. So here the first number is 10, 15, 11. That means the equivalent numbers are A, F, B, base 16. So you are writing this number. That means 2811 decimal number for this equivalent number is AFB base 16 like this. So this is how to convert given by what is a decimal number. So decimal number system into all other systems. So when we are converting the decimal number system with binary, we have to divide with 2. When we are converting the decimal number with octal, so we are dividing with 8, and when we are converting decimal number into hexadecimal, we have to divide with 16. So all it is same process, but what is the simple thing you have to remember is the base numbers based on the resultant conversion number. So we are changing these bases. So in the next case, so when we consider the octal number system, so here how to convert the octal number into binary conversion. So already we have seen that. So when we are converting that binary number into octal number system, so we were dividing that given binary number in a format like 3 numbers as one group here. So the exact opposite case here in this case we are getting that is the number, it is given, octal number is given. So the octal number is just we are writing that into a binary format of having three numbers. So for example, when it is having 35.346, so in this case, so directly we are writing that the given number into that what is the binary number of having three digits as one group, three digits as one group, like 3 as 001 and 5 as 101. So the binary point is keeping the same, like that only. And next 3 as 0114 is 100, 6 is 110. Just we are writing that given octal number as a three group of binary numbers, same as the exact opposite for the binary to octal number. In the next cases, we will see that how to convert that octal number into the decimal number.